Hello, you guys. This is for our class for Monday the 1st, or for Tuesday, Thursday class. It is for Tuesday, February 2nd. During this class, we're going to talk about systems of equations. There's three ways to solve systems of equations. The first that we're going to do is by graphing. Also, we could do by, we can solve systems by substitution, and the third way is by elimination. So if you have two lines, so two linear equations that intersect at one spot, that intersection is actually considered the solution. So on a graph, well, anytime there is a solution, we're going to find the solution by an ordered pair. So basically that ordered pair would describe where two linear equations intersect each other, where they meet, okay? So it says determine if points lie on both lines in specified systems of equations. Determine by graphing if systems of linear equations are consistent, inconsistent, or dependent. So when we solve these, we're either going to find out that they have one solution, which means they intersect one time, which we're going to use the word consistent. Inconsistent means that they will never intersect. And so, of course, that means if you have two lines that never intersect, that means those lines are parallel. And the third one is dependent, which means basically, even though it looks like we might have two different equations, when we graph them, we find out they're both the same line. And so actually every single number that you can think of is part of the solution set. All right, so let's get started. So here we have two equations. So when we say system of equations, that means more than one equation. So on the ones that we do, we're going to have two equations. And we want to know of these two equations, this is our set, is this ordered pair a solution to this set? Okay, so basically what we're going to do is we're going to substitute these values for x and y and see if we get two true statements. So for example, if x is 2 and y is 1, we're going to plug this in, see if it's true. Well, 2 times 1 is 2, and 2 minus 2 does in fact equal 0. That is true. So we got one true statement, but we have to have two true statements. So we're going to plug in 2 for x again. So 3 times 2 plus 1 for y. And of course, 2 times 3 is 6, and 6 plus 1, is in fact 7. So we get two true statements. So the answer is yes, this ordered pair is a solution to the system. And we prove that by plugging them in and evaluating the value. Now, this is telling us already that this ordered pair is not a solution. So we want to see why. So we're going to plug in for x and y. The first number is always x. The second number is always y. So if y is 4, x is, well, negative 0. There's no such thing, but that would still be 0. But this is true because 0 plus 4 is in fact 4. So you might think, well, this might be a solution, right? But we have to make sure it works for both of the equations. So once again, y is 4, x is 0. Well, 2 times 1 is 0. 2 times 0 is 0, and 0 plus 1 does not equal 4. So even though we have one correct statement, this one is not true. That means that this ordered pair is not a solution for the whole system, and the whole system includes both equations. There are three different types of solutions to systems of linear equations. You can either have an infinite number of solutions, which means that the two equations are the same line. Basically, one line lies on top of the other. We could have no solutions, which we would use the word inconsistent, which means our two linear equations are parallel lines, or we have one solution, which means there's one place where our two lines intersect. All right, so the first one we're going to look at if those two solutions the two lines are dependent. It says a system of linear equations has an infinite number of solutions if the lines are identical. This means the lines coincide. Also, you have two equations that you only see one line. For example, we have two different equations here. The first equation, we're going to graph it. We start with our y-intercept, which is at 0, 2. So 0, 2, that's right here. And then our rise is 4 and our run is 3, and it's a negative slope. So that says we're going to go down 4, 1, 2, 3, 4, and right 3, 1, 2, 3. So that's how we graph that line. And then the second line, if we solve for y, we're going to subtract 4x from both sides. So we'd have 3y is equal to negative 4x plus 6. And then we divide everything by 3. So y equals negative 4 over 3 plus 6 divided by 3 is 2. So notice these are identical, right? So if we wanted to graph this, we would do the same thing. Our y-intercept is 0, 0, 2. So we put a dot right here. Our rise is 4. It's negative, so we go down 4. 1, 2, 3, 4. Our run is 3. 1, 2, 3. And we would connect the dots. And even though we started out with two equations, we end up with exactly one line, which means that they are the same. So they're the same equation basically, right? So it says coinciding lines have two things, the same slope and the same intersect. So like I showed you when we solved for y on the second equation, we ended up with two identical equations. So that means every single point on these two lines that they both have those things in common, right? That's why they have an infinite number of solutions. And you would say the same two lines, the same line are dependent. They're dependent on each other. All right, now we have two lines that never intersect. That means that they will have no solutions. A system of linear equations has no solutions if the lines are parallel. It means the lines do not intersect. So if you notice these two lines, like we talked about last week, if you have two parallel lines, they have the same slope. But since it's two separate lines, they're going to have two different y-intercepts. So the bottom one's y-intercept is 0, negative 3. So we find that 0, negative 3 right here. And the top one, the y-intercept is 0, 2. So up here at 0, 1, 2. And then the slopes are the same. We go down 4, right 3, 1, 2, 3, 4, 1, 2, 3. Same thing down here, 1, 2, 3, 4, 1, 2, 3. And we draw our lines. We find out they do not intersect, which means they do not have any solutions. And we would use the word inconsistent. Now in Hawks, you have to use one of those three words. Dependent, if they lie on the same line. Inconsistent if they're parallel, and consistent if you have one intersection. Remember, parallel lines have the same slope, but different y-intercepts. All right, finally, we have two lines that are, they intersect. So if we graph the first line, so if we look at the top one up here, we see that our y-intercept is 0, 2. So 0, 2 right there. And then this, basically there's a 1 right here. So if we wrote this as fraction form, it'd be negative 1 over 1. And it's negative, so we would go down 1, right 1, down 1, right 1, down 1, right 1, so on and so forth, and draw that red line. And then the bottom one, our y-intercept is 0, negative 2, which is right here. And then this is a positive 1 over 1. So, and it's positive, so we go up 1, right 1, up 1, right 1, up 1, right 1, so on and so forth. And we find out that those two lines intersect at 1, 2, 2, 0. That is the solution to this system because that's where these two lines intersect. Intersecting lines have different slopes. That's not always true. That's not always true. I'll have to disagree with that statement. But anyway, most of the time it is. All right, so the point of intersection is 2, 0. All right, so now we're going to solve by graphing, and you're going to do examples like this in Hawks. So you are going to graph both of these lines. So remember, this only has an X. So when you see an equation with only an X or only a Y, you think of the acronym Bucks. Ooh, do it. You think of the acronym Bucks Hoy. All right, and you go, oh, okay, it's an X, which means it's a vertical line. So we're going to go over here on the X-axis and find the number 2, 1, 2. We're going to draw a vertical line anywhere on this X-axis. I mean, not X-axis, but where X equals 2. And then we're going to graph the other line. So let me change colors. So I'm going to start with our y-intercept. So our y-intercept is when X equals 0, that's our y-intercept, our y value. So we're going to go, don't go right or left, go down 2. And then our rise is 3. If we wrote this as fraction, it'd be 3 over 1. And it's positive. So from here, we're going to go up 3, right 1. 1, 2, 3, 1. Do it again. 1, 2, 3, 1. And I could almost do it again, be up here. So don't forget your rise. If it's positive, you go up. And then your run is always to the right. So if I should have made my blue line a little longer. This blue line would go all the way down your graph as a vertical line. It could go forever. And then that red line, oh man, did I erase it? No, sorry. So then if we connect our dots, so hard for me to draw a straight line. So bad. All right, but you see that these two lines intersect right here. So first of all, the word we would use is, let's see, consistent. If there's one solution, we're going to use the word consistent. And then where they intersect, that is the solution. So what is this ordered pair right here? Well, from here, I would go right 2, up 4. So 2, 4. So that is, if I plug in 2 for X and 4 for Y, both of these statements would be true over here. Okay. All righty. What about this one? All right, we're going to do 2 different colors. We'll start with red. So we start with our y-intercept. So 0, 4. Don't go right or left, but go up 4. And then we have a positive slope. So we're going to go up 2, right 3. 1, 2, 1, 2, 3. All right, so I'm going to, even though I would want to keep going up a couple, I'm going to do the opposite. Instead of going up 2, right 3, I'm going to make this longer by going down 2, left 3. 1, 2, 3. I just want to make sure I have that positive slope. Ooh, so bad. There we go. Hopefully that's long enough. Oh my goodness, you guys. All right, now let's change colors. Let's do that blue. So here we're going to do 0, 1. That's where we start graphing. 0, 1. And then it's negative. So we're going to go down and right. So we're going to go down 1, right 3. Down 1, right 3. 1, 2, 3. Uh-oh. My pen turned off. Where's my blue pen? Down 1, right 3, 1, 2, 3. Well, obviously my lines aren't going to intersect down here. They're going to intersect up here. So instead of going down and right, I'm going to do the opposite. I'm going to go up and left. 1, 2, 3. Up, 1, 2, 3. So here I see, if I connect these dots. Oh my goodness, stresses me out. All right, so our two lines intersect, so we know they're consistent. Hopefully you're doing this with me on your paper. And what is this coordinate? So if I start at the origin, I go left 3 up 2, left 3 up 2. So if I plugged in X, 3 for X and 2 for Y for both of these equations, we would get correct answers. All righty. All right, let's do another one. So we're going to start at 0, 3. Our y-intercept is 0, 3. Don't go right or left, go up 3. And then our slope is -2. So that means down 2, right 3, down 2, right 3. So our rise is 2, -2, 1, 2, right 3, 1, 2, 3. We could do it again, 1, 2, 1, 2, 3. And here is our top line. And then the bottom one, let's go with red. Come on, let's go with red. All right, our y-intercept is 0, -1. Don't go right or left, go down 1. Our rise is -2, so down 2, 1, 2, right 3, 1, 2, 3. We could do it again, down 2, right 1, 2, 3. And when we connect our dots, we could say, oh, wait a minute, these lines won't ever intersect because they are parallel. And we can double check by checking the slope and going, okay, yeah, remember that parallel lines have the same slope. So since they will never intersect, we would say that they are inconsistent. They have no solution. And so that's what we would say, no solution, because they are parallel. All right. All right, let's look at this one. The top one, our y-intercept is 0, -4. So we're going to start down here, 0, -4 right here. -2, if we made this a fraction, be over 1. So -2, that means we go down 2, right 1. From here, we go down 2, right 1. We're out of space. I do want this to be a little longer, so I'm going to start where I got at my y-intercept, and instead of going down 2, right 3, instead of going down 2, right 1, I'm going to do the opposite. I'm going to go up 2, left 1, just to make my line a little longer. All right, pretend that's straight. Now my second one, look at my second equation. It is not in slope-intercept form. I have to solve for y before I can graph it. So the first thing I want to do is subtract x. So I'm going to have -3y is equal to -1x minus 9. Now I'm going to divide by -3, -3, -3. That's gone. Y is equal to a negative divided by negative is positive, and I'm going to leave it in fraction form. And then -9 divided by -3 is +3. Okay, so I'm going to graph starting with my y-intercept, 0, 3. So 1, 2, oh, it's positive, I'm sorry. 1, 2, 3 right here. And then my slope is positive, so I'm going to go up 1, right 3. 1, 2, 3. Up 1, right 1, 2, 3. Now, obviously, they're not going to intersect up here, so I got to do the opposite. I'm going to go down 1, left 3. 1, 2, 3. Well, if you notice the red line, it looks like this is where they would intersect if I made my lines long enough. Now, if I had a ruler, I could just draw with my ruler. I wouldn't have to make all these individual dots. I could just make my line really long with my ruler. But since I don't have a ruler, I want to be exact with these points. So I'm going to go back up to the top line. And we started off with 0, -4. Then we went up to left 1, up to left 1, up to left 1. Yep. So look at that. That's exactly where these two lines would intersect. So there's one solution, so that means they are consistent. And it's once you, in HOTS, once you click the button that says consistent, it's going to ask you what the solution is. So that's when you have to write the ordered pair where they intersect. So -3, +2. -3, +2 is the solution for this system of equations. All right, let's do these two. Now, neither of these are in slope-intercept form, so we have to solve for y. So I'm going to write the bottom one down here so I can solve for y. So I'm going to subtract x from both sides first. So that's gone. So I have -3y is equal to -1x minus 12. If you don't see a number, it means it's always a 1. Now I'm going to divide every single term by -3. So y equals negative divided by negative is +1/3, and -12 divided by -3 is +4. So my y-intercept is 0, 4. And then I have a positive slope. So my rise is 1, my run is 3. 1, 2, 3. I could do it again. Could go up 1, 1, 2, 3. If I want to make it longer this way, I'm going to go back to my y-intercept and do the opposite. I'm going to go down 1, left 3. 1, 2, 3. Down 1, left 3. All right, so here is my top line. Now I'm going to change colors. Let's do blue. I'm going to subtract 2x from both sides. Bring down my y equals -2x minus 3. All right, so I'm going to come down here to 0, -3, right here. I have a negative slope of 2. That means I'd go down 2, right 1, correct? But I'm out of space, you guys, and I want to make sure my line comes all the way up in this area up here, right? So this time I'm going to do the opposite. Instead of going down 2, right 1, I'm going to go up 2, left 1. Up 2, left 1, up 2, left 1, up 2, left 1. So that I want to make my lines long enough so I can see where they intersect. And I see right there, this is where they both intersect. So what is this ordered pair? So first of all, what's the word? The word is consistent. And then my ordered pair is -3, 3. -3, 3. And that is my solution. All right, I think I got a few more. Are you guys doing these with me? I'm just curious how far. All right. All right, let's look at this one. Just a lot of good exercise for us. A lot of good practice, right? All right, let's do the top one. Got to solve for y. So I'm going to bring this down here. X minus y equals -1. I'm going to solve for y by subtracting x from both sides. Bring down my minus y equals -x minus 1, but I haven't solved for positive y. The only way to get rid of that negative sign is I divide everything by -1, -1, -1. Now negative divided by -1 is positive, so positive y. A negative divided by a negative is positive x. And then -1 divided by -1 is +1. All right, my y-intercept is 0, 1. And then my rise is 1/1. So +1, up 1, right 1. Up 1, right 1, up 1, right 1, so on and so forth. Do that forever, couldn't I? All right, on the bottom one, let's get rid of 2x. Oh, I need to change colors so I can see my different lines. So I'm going to bring down -2y is equal to -2x minus 2. And then I divide every single term by -2. So I have y equals -2 divided by -2 is +1. 1 times x is x. If I want to make that a fraction, I'd use 1 over 1. And then -2 divided by -2 is +1. So guess what, guys? We get the same line, don't we? 0, 1 is my y-intercept, up 1, right 1, up 1, right 1. And I could just keep on doing that. So it's two lines that lie on top of each other, which makes them have an infinite number of solutions. Infinite solutions. And what word goes with that? Dependent. They're the same line. The lines are dependent. All right, you guys, hopefully by now you've been able to pause the video and try these on your own. So you guys do that. If you haven't so far, go ahead and try the last couple by yourself, okay? And then check your answers with me. All right, on the top one, we're going to start with +3, 0, +3, 1, 2, 3. And then we have a -5, that means down 5, right 3. So from here, we're going to go down 5. Where's my pen? 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3. I don't know if that's long enough, but we'll see. All right, let's choose another color. We'll do red, easy to see. All right, our y-intercept is 0, -3. 1, 2, 3, and then our rise is 1 over 3. So rise 1, up 1, right 3, up 1, right 3. 1, 2, 3. We already see our intersection. 1, 2, 3. So we have one solution. They intersect, which means consistent. And that solution is 1, 2, 3, -2. 3, -2. All right, the next one, we're going to start with our y-intercept, which is 0, -4. 0, -1, 2, 3, 4, and our rise is 3, so 3 over 1, correct? Rise 3, up 3, right 1. 1, 2, 3, 1. 1, 2, 3, 1. 1, 2, 3, 1. There we go. And then the bottom one, our y-intercept is 0, 3. So we're going to start up here. And then we have -1, so down 1, right 2. Down 1, right 2. Down 1, right 2. There's our intersection. So we're going to write consistent. And that solution is 2, 2. 2, 2. That's it. All right, so this is example 3. Graph the linear equations by writing the equations in slope-intercept form. Identify the appropriate number of solutions. And then it'll say, given x equals -5, determine the value for y. All right, so the first thing we're going to do is write in slope-intercept form, which means we're going to solve for y. So we want to get rid of this -4x. We're going to add 4x to both sides. So we have 2y is equal to 4x minus 12. And then we're going to divide everything by 2. So we have y is equal to 2x minus 6. All right. And then the right one, well, let's go ahead and graph this. So our y-intercept is 0, -6 right here. And then we have 2 over 1, up 2, right 1. Up 2, right 1, up 2, right 1, up 2, right 1. I don't know how long we need to make that, but we'll start right here. All right, let's add 10x to both sides. Add 10x. So we're going to bring down 5y is equal to 10x minus 30. And then we're going to divide everything by 5. So we have y equals 2x minus 6. So guess what? We have the same 1, 2, 1, 1, 2, 1. We have the same two lines on top of each other. So that means an infinite number of solutions. Infinite number of solutions. And what's our word? Our word is dependent. And then it says, given x equals -5, determine the value for y. Well, if x equals -5, so -5 would be right here. So that means that y would be way down here, wouldn't it? Be way down here. If we continue this line, I mean, I could guess what it would be. It would be way off of our graph down here, because we want it to intersect right here somewhere. Ooh, what did I just do? Or what I could do is I could take my equation, plug in. I'm going to take a simplified version of my equation, and I'm going to plug in -5 for 2. So 2 times x, which is -5, minus 6. So I'm plugging in -5 for x right there. Well, 2 times -5 is -10. And -10 minus 6 is 16, -16. So it asked me, given x equals -5, determine the value for y. So if x is -5, y would be -16. Like I said, it'd be way down here off of our chart somewhere. Okay, so that's how you do that. You just take any of the equations. We could take this one, we could take this one, we could take this one. If we plugged in -5 into any of these 4 equations that I circled, we're going to get the same y value, the same exact y value. All right, then it says determine if the point -4, -3 lies on both of the lines. All right, so we don't even have to graph this one. We're just going to take this this ordered pair. We're going to plug those values into both of our equations, and if we get true statements for both of them, the answer is yes. If either one of them is no, that is not a true statement, then the final answer is no. Okay, so we're going to plug in -4 for x and -3 for y. So if if x is -4, 2 times -4 plus 2 times -3 equals 12. We want to see if that's true. Well, 2 times -12 is -8. And 2 times -3 is -6. And we will see that that's not true. -6 plus -8 is -14. So we don't even have to try the second one. The first one's already proven that this is not a solution. So I'm going to say no on the first one. All right, let's check out the second one. The second ordered pair, they gave us 3, 3. We want to see if it's a solution. All right, if x is 3 and y is 3. Well, 6 plus 6 is 12. I know that's true. Let's try the second one. 4 times 3 minus 2 times 3. Well, 4 times 3 is 12, minus 6 is 6. That's true. So yes, this is a solution. The top one, nope. The bottom one, yes. So you just plug in, substitute, and figure out the answer for those. All right, so that was 8. I don't even know what it was, but anyway, we're moving on to 8.1. So now we have just solved systems of equations by graphing. Now you don't always have a graph. Sometimes you have to solve it a different way. So this is just reminding you the types of systems are either inconsistent, which means no solution, or consistent, which means that there's exactly one solution, or dependent, which basically is the same sign, the same line lying on top of each other. We're going to be solving by substitution, where we solve for one variable and plug it into the other equation. And then we also are going to try to solve by elimination, which is my favorite way to solve, by the way. We'll get there last, I suppose. All right, so the first one tells us to use substitution. So do you see where it tells us we're going to solve this system by substitution, okay? So that means we take probably what I would describe as the simplest equation, and we're going to solve for either X or Y. So look at that first equation. There's less steps to solve for X or Y than the second one, right? And in fact, there's only a Y, there's not even an X. So I want to solve for Y, and the way I would do that is divide both sides by -5. So the top one, I'm going to solve for Y. Y equals 15 divided by -5 is -3, okay? Now, since I've solved the top one for Y, I'm going to substitute the value of Y into my other equation. So this is telling me that Y equals -3. So instead of using a Y right there, that's where I'm going to plug in. I'm going to substitute -3 for Y. So in my second equation, I'm going to bring down my X, my -4, and now here's where I'm substituting -3 for Y and bringing out everything. I'm bringing down everything else. Well, X, -4 times -3 is +12. Bring everything else down. Now I'm going to subtract 12 from both sides. So X is equal to -3. Now remember in the first section, whenever we had where they crossed, we had to write our equation as an ordered pair. Well, that's what I'm going to do this time. Remember, you write X first and then Y. So my solution to this system is -3, -3. -3, -3. That is my solution. There's one solution and it's -3, -3. All right, so now I'm going to solve again for the simplest equation, which in this situation is going to be the second one. So the second one, I see there's only one step to solve for X. That's by dividing both sides by 2. So I just solved that X is equal to 2 divided by 2 is 1. So I know the value of X, it's 1. I still have to solve for Y, and that means I have to solve the other equation. So I'm going to plug in right here for X, I'm going to plug in a 1. I'm substituting a 1 for X. So 8 times 1 plus 4Y equals -24. 8 times 1 is 8. And now I'm solving for Y by subtracting 8 from both sides. So I bring down 4Y equals -24 minus 8 is -32. And then I divide both sides by 4, and I find out that Y is equal to -8. So I have one solution, which means consistent, and that solution is 1, -8. All right, let's look at example 3. Now this tells us to use substitution. I would use elimination, but I guess it's fine. We'll just use substitution since it tells us to. Now the last few tells us to do elimination. Well, let me just show you elimination because, like I said, I would not solve this by substitution. So let me go to a harder one. All right, let me find, an easier one. That's what I meant to say. All right, so let's start with, let me just make up a problem real quick. All right, so you're going to write this on your paper. All right, so let's say I had -2x plus 4y equals, I don't know, 8. And then I also had positive 2x minus 2y equals 10. And the directions said to solve this system of equation by elimination. Well, what you want to do is you're going to think of this as a big plus addition problem, okay? So then the reason I did elimination is because look at my x's. If I tried to combine -2x and positive 2x, don't I get 0? Don't my x's go away? All right, they're gone. So I just eliminated my x's. That's why it's called elimination. Now look at my y. So I have 4y combined with negative 2y. Well, 4y minus 2y is 2y, and 8 plus 10 is 18. Well, now to solve for y, all I have to do is divide both sides by 2, and I would find out that y equals 9. So by eliminating my x's, that's a pretty easy way to solve for y, right? I'm done. I just have to. Then after I solve for y, I would go back to one of my original equations. It doesn't matter which one I choose. I would plug in y in one of the two places, and I would solve for x. So I'm going to pick the bottom equation. So the bottom equation says 2x minus 2y equals 10. I decide I'm going to substitute 9 into this equation. So I'm going to substitute 9 for y. So 2x minus 18 equals, I don't know why I wrote 20, I meant 10. And then I would add 18 to both sides, and I'd have 2x equals 28, and then half of 28 is 14. So my solution would be 14, oh shoot, what did I just do? Oh, well, I erased the whole thing. No, I didn't. All right, so my whole solution would be 14,9, okay? But I would definitely use elimination because my x's naturally canceled each other out, right? All right, so now even though this isn't the same number, see how I had the same number but opposite signs? So my x's are not the same numbers, but they are opposite signs. So I know the way I could get rid of a negative 8 is to combine it with a positive 8, right? Well, can I multiply 2 by 4 to get positive 8? So basically, I would multiply this whole top equation by 4 because I want my x to be equal to positive 8x so that I can eliminate this negative 8x. So I'm going to multiply the entire equation by 4, and I'm going to rewrite it right here underneath this one. So 4 times 2x is 8x. 4 times negative 3y is negative 12y equals 4 times 2 is 8. All right, so let's see what happens here. Well, negative 8 and positive 8 is 0. Positive 12 and negative 12, actually, I got rid of both of those. So on the left side of my equal sign, I have 0. And on the right side of my equal sign, I have negative 2. So I tried just eliminating my x's, but I ended up eliminating both of my variables, actually. And then when I got down to this answer, is this true? Does 0 equal negative 12? No. When you come across an incorrect statement, that means it's inconsistent. If you end up with an incorrect statement, your answer is inconsistent. Do you remember which ones are inconsistent? It's the parallel lines. So these are two parallel lines. If I graph these two equations on a coordinate plane, I would get two parallel lines. Here's some water. All right, so once again, now this one I wouldn't mind using substitution because my x is by itself. So it tells me to use substitution, so that's what I'll do. I'm going to solve for x, and then I'm going to plug in whatever x is into my other equation. So I'm going to bring it over here, x plus 5y equals 8. So I'm going to solve for x. It doesn't matter if you solve for x or y. I'm going to solve for whichever one is more simple. And this x, I don't have to divide anything to get x by itself, right? So I'm going to bring down my x equals negative 5y plus 8. Now, I just solved for x. I just said that x is negative 5y plus 8. So I'm substituting this x right here with all of this. That's why I put it in parentheses. If you get a long expression, make sure you put it in parentheses. So we're doing substitution. That's why I'm doing this. All right, so in the bottom equation, I'm going to bring down my -4. -4 times x, and in this situation, x is -5y plus 8. Now bring everything else down. Minus 20y is equal to -32. I'm going to use the distributive property. Negative times a negative is positive 20y. Negative times plus 8 is -32. Minus 20y equals -32. Are you with me? All I did was distribute. And now I have to combine like terms. Well, 20y minus 20y is 0, right? So my y's cancel each other out. I'm left with the -32 is equal to -32. Is that true? Yes, that's true. So when I get down to my last line, if I've eliminated my x and my y and I end up with a true statement, that means that remember, an incorrect statement meant inconsistent, but a true statement is going to be dependent. So basically, these are the same dependent. These are the same line. They're the same line on top of each other. Okay, now, well, that's fun. So if you end up with an incorrect statement, that's inconsistent. If you end up with a true statement and you've eliminated all of your variables, that means you have a dependent system. If not, you end up with x equals and y equals, which means that's one solution, which is consistent. All right, so we still need to do some elimination and word problems. So even though I'm going to skip this section. I do want you guys to try these by yourself. I'm not going to take the time because I don't want this to be an hour long. I don't even know how long I've been doing this, but when you come to class tonight on Monday, I will answer these questions for you. I'll give you the solution for them. Okay. I'm not going to take the time to work them out right now, but I challenge you guys to do them. But I do want to do a few more of these elimination. So let's look at the top one up here. So the way these are written, my x's will eliminate themselves, correct? I don't have to multiply by anything. So my x's, I'm going to make this a big plus symbol. So my x's are gone. Now I'm going to add my y's. 8y plus 2y is 10y equals 20 combined with -30 is -10. Now to solve for y, I divide both sides by 10. So y equals -1. That was easy, wasn't it? But now I have to solve for x. So I'm going to take -1. I'm going to plug it into either one of these equations. It doesn't matter which one. So I'll just do the top one. So so now I'm substituting for y because that's what I solved for, right? So on the top equation, I'm going to bring down 4x plus 8 times -1. I'm substituting for y equals 20. So I have 4x minus 8 equals 20. I'm going to add 8 to both sides. So I have 4x equals 28 divided by 4, and y equals 7. So write your answer in ordered pair, 7, -1. That's the answer. All right, the second equation, now 10 and 5, really what you want are opposite signs. You either want the same number or opposite signs, or like the first one is best case scenario. You have the same number but opposite signs already, which is the best, that's the easiest one to do. So I'm going to use my y's. So these are already opposite signs, correct? So I want to make the top one positive 7y. So my 7's will go away. Excuse me, my y's will go away. So what do I multiply 1y by to get 7y? Well, that means I'm going to multiply by 7. Can't just multiply the y by 7. You have to multiply the whole equation by 7. So I'm going to bring down that equation down here. So 7 times 5 is 35x. 7 times 1y is positive 7y. And 7 times 9 is positive 63. So I'm going to make a big plus symbol. I know my y's go away. So 10x plus 35x is 45x equals 63. So what is 63 minus 18? That's also 45. So now I'm going to divide both sides by 45, and I get x equals 1. Oops. X equals 1. And now I can plug 1 into the top or bottom. I'm going to do the top because my numbers are smaller. 5 times 1 plus y equals 9. So I have 5 plus y equals 9. I'm going to subtract 5 from both sides, and y equals 4. So my x is 1 and my y is 4. And that's the answer. All right. All right, look at this one over here. I'm not going to solve that one right here. I'll save this for later as well. So come to class tonight and I can tell you the answer. So go ahead and try that one by itself. I would go ahead and multiply. Neither of those are good, is it? I would make, since the y's are already opposite signs, I would try to make the y's the same number. So I know that y, so 4 and 9, what do they have in common? 36, right? So I would multiply the whole top by positive 9, because 9 times 4 is positive 36. And the bottom I would multiply by positive 4, because 4 and negative 9 is negative 36. So I'll help you out that way. Now I want you guys to try that on your own. Now look at this one. So look at our x's. They are the same number, but they're also the same sign. So the only way to make one of them a positive 6 is if I multiply the whole equation by negative 1. And I'm multiplying by negative 1 so I can eliminate my x's. So I'm going to bring this down here. So negative 6 times negative 1 is positive 6x. Negative 1 times 6y is negative 6y. And then negative 1 times 6 is negative 6. So I'm combining the bottom two. The top one I'm totally ignoring. Ignore. I'm looking at these two, right? Negative 6 and positive 6x are 0. Go away. 3y minus 6y is negative 3y. And negative 12 plus negative 6 is negative 18. When I divide both sides by negative 3, y is positive 8/3. Negative divided by negative is positive 8/3. And now I'm going to substitute 8/3 for y into this bottom equation down here. So I'm going to bring down my 6x plus 3 over 1 times 8 over 3. Substitute for my y's equals negative 12. Negative 6x, now my 3's go away, right? So 8 over 1, multiply straight across. 8 times 1 and 1 times 1. So 8 over 1 equals positive 8 equals negative 12. And then I subtract 8 from both sides. So I end up with negative 6x equals negative 20. Then when I divide both sides by negative 20, I know what negative divided by negative is positive 20 over 6, which will be 10 over 3. So my x is 10 over 3, and my y is 8 over 3. And that's my solution. Okay? All righty. Let's get on some word problems. I have no idea how long this video is. Hopefully it's not so long. So Julie has 26 coins. Some are dimes and the others are quarters. She has a total of $3.65. How many dimes and how many quarters? So you need two equations for all of these word problems. So the first one has to do with the number of coins. So she has some dimes plus some quarters equals 26 coins. You understand? She has 26 coins. So the number of dimes plus the number of quarters equals 26, right? Now the next equation has to do with how much they're worth. So a dime is worth 10 cents. So 1 dime is worth 10 cents. So I would multiply 10 cents times the number of dimes I have, plus quarters are worth 25 cents. So 25 times the number of quarters I have. And I want to know what combination gives me $3.65. So this is my system of equation. I'm going to take that top equation. I'm going to solve for D. So I'm going to subtract Q from both sides. So D is equal to 26 minus Q. So now I'm going to substitute this for D in this equation on the bottom. I'm using substitution. So I'm going to bring down my 0.10 times D, and D is 26 minus Q plus 0.25 Q equals 365. And now I'm substituting. So 0.10 times 26 is 0.26. 0.10 times negative Q is minus 0.10 Q plus 0.25 Q equals 365. I'm going to combine these like terms. So negative 0.10 plus 0.25 is 0.15 Q. I forgot to bring down, oh, and that's a positive. I forgot to bring down my 0.26. So now I'm adding 0.26, or no, I'm not. I'm subtracting 0.26 from both sides. So I have 0.15 Q is equal to 365 minus 0.26, which is 339. Uh-oh, I messed something up. And now I'm going to divide both sides by 0.15, which isn't right because it's not going to be a whole number. What did I do? Divided by 0.15. 22.6. What did I do, guys? I messed up. Oh, no. I messed up. It's not a whole number. Anyway, if I had 22 quarters, that's way too much money, isn't it? Oh, it's not 0.26. Yes, it is. So 26 times 0.10. Oh, it's supposed to be 2.6, not 0.26. It's 2.6, 2.6. So anyway, I was supposed to subtract 2.6, which is 1.05. That's what I should have right here. When I subtracted, I should have 1.05, and 1.05 divided by 0.15, and that's not right either. 3.65 minus 2.6 divided by 0.15. Yeah, it's 7. Sorry. So I should have 7. Oh, I messed that up. I'm running short and now I'm getting all flustered. All right. So anyway, I messed up this multiplication. This right here should be 2.6. 2.6. And when I subtracted 2.6 from 3.65, I should have got 1.05, and then I would have divided 1.05 by 0.15, and I would have got 7. So 7 quarters. So Q equals 7. So if I have 7 quarters and 26 coins, I should have 19 dimes. 19 dimes and 7 quarters is 26 coins. And if you check the math, 7 quarters plus 19 dimes should be $3.65. So sorry about that. All right, we got to move on. So the admission fee at a local zoo is $1.50 for children and $4 for adults. On a certain day, 3,000 people entered, it should say entered the zoo, and that much money was collected. All right, so you need 2 equations. One's for how many tickets they sold, and the other one's how much money they made. One's about tickets, one's about money, just like the coins. One was about coins, one was about the value. Okay, so we have the number of children's tickets plus the number of adult tickets equals 3,000 tickets. The other one's all about the money. The money is $1.50 per child, so 150 C, plus $4 per adult, so $4 per adult tickets equals how much money they made, 7,250. All right, now we could do a couple of things. Since I have two A's lined up here and it's easy to get rid of a positive 4A, I'm going to multiply everything by -4. I'm going to use elimination. So I'm going to pull this down here. -4 times C is -4C. -4 times A is -4A. And -4 times 3,000 is -12,000. Okay, so I am combining those two bottom equations. So -4, don't make a mistake on this part, -4 plus 1.5 is -2.5 C. My A's cancel themselves out. And then I have -12,000 combined with a positive 7,250, which is -4750. Then I'm going to divide both sides by -2.5, -2.5, and I end up getting the number of children's tickets is 1,900. So then if I plug in 1,900 right there for C, if we sold 3,000 tickets and 1,900 of them were children's tickets, that means 1,100 were adult tickets. 1,100 plus 1,900 is 3,000 tickets. All right. Desmond goes to a fast food restaurant and orders some tacos and burritos. He sees on the nutrition menu the tacos are 140 calories and burritos are 320. If he orders 6 items and consume 12,000 or 1,200 calories. All right, so we have tacos and burritos equals 6 items. And then the other equation is only about calories, right? So of the 6 items, they were tacos plus burritos equals 6. Now tacos are 140 calories per taco, plus burritos are 320 calories per burrito equals 1,200 calories. So I can just do what? You can solve for T if you want to by subtracting B. So tacos equals 6 minus B. So I'm going to substitute 6 minus B for T because T is 6 minus B. So I'm going to do 140 times 6 minus B plus 320, B equals 1,200. So 140 times 6 is 840. 840 minus 140B plus 320B equals 1,200. So 320 minus 140, combine like terms, I get 180. So we have 840 minus 180B equals 1,200. We're going to subtract 840. And I get 360. So negative 180B minus or equals 360. Oh, this is positive. Yeah, sorry. This is 360, and 360 divided by 180 is 2. So Desmond got 2 burritos. If he got 2 burritos, that means he got how many tacos if there's 6 total items? So 4 tacos and 2 burritos, which is 6 food items. Okie doke. All right, we got 4, 5, 6, 7. Goodness. All right, and then make sure, so I will, if you want me to help you with those last few, I will do that during class. I don't want to take any more of your time. I feel like we're almost at an hour. If I'm not over already, I'm not really sure. But make sure you read your study session discussion, and I will see you guys. I'll be live at 6 o'clock. I'll help you. Oh, you have 2 study skills sessions. I will help you on those last few that we didn't get to, but I hope that helps. A lot of those problems are on Hawks, the ones that I've already worked out for you. So I will see you guys Monday night at 6, or anytime you want to log in if you have any questions. But bring up your Hawks homework and let's talk about the ones that you are confused on. All right. So I will see you guys during class, and have a good day. See you later.